ended with we started on else dictionary, looping through dictionary items, as well as we saw for else, while else. I asked you guys to work on. If you want, I can walk you through. If you guys tried, it is good. And what else we saw is lambda functions we saw, and a few other concepts, iterators we saw. So on that iterators list, there is one more concept called generators. And today we are going to see what is generator and how we are going to use it. And have some concepts like map, filter, reduce. So these things we didn't cover in the past, I guess. So we'll cover those things today. And I believe we have covered membership operators. In case it was not covered, I will give a brief idea what is it memberships. Okay. And finally, we are going to look into error handling of how the error handling can be done using Python. And then we'll move on to file IO. Okay. So how we can read and write a file. Okay, these are the concepts we are going to look, and which we didn't touch is OOPS. Okay, OOPS is nothing but object oriented programming language. So object oriented programming system in which we have lots of class and class concepts mainly comes. Okay, class inheritance and what are the function overloading. There are plenty of concepts inside OOPS if we go, but that is not within the scope of this program, so we couldn't cover it. It needs a separate sessions. Okay, so I don't want it to mix up. So whatever we are giving is what are the concepts available in Python apart from OOPS. Okay, so OOPS, if you wanted to take, it will take another minimum 10 hours of session we will be needing to cover up. Okay, but uh, yeah, so these are the topics we are going to cover. So with that, we'll start. So I'm just dropping this hoops right now. I will not give any picture on that. We'll come back if time permits. Okay. So let's start with generators. Okay. Okay. So you might have noticed whenever I'm just creating a list, I've been using this way. Okay. A list of a range of 10. Okay. Why can't I use like a range of 10 only? Why I wanted to use this list? Because the main reason for this is range of 10 will not give you the complete list of items. Okay, that's the difference, main difference. So range, actually the range function actually returns a generator. Okay, range function returns a generator. So what is a generator first? So generator is something, so when you know, see, suppose you wanted to use the values from 0 to 100. Okay, instead of defining a memory for that 0 to 100, we can have a function. Whenever I call that function, it will generate that particular value. First time if I'm calling, it will give 1. Second time if I call the same function, it will give 2. Likewise, if you do, we don't need to have a storage space. So when it comes to programming, memory is also one of the cost. Okay. So programming cost, when you're saying time to execute, that is like when you're calculating the cost of a program. So what we do, how much time it takes to execute. One is the performance cost. Other factor is memory. So memory is one of the big concern here. Okay, so if you use generator, suppose you wanted to use 1 lakh numbers, which is like 1 to 10,000, we are going to sequentially access these values. In that case, we may not require to use we may not require to create a list of 1 to 1 lakh, because that much memory will get allocated in the RAM space, which is like unnecessary burden to the system. Okay, so to avoid that, so we know this is the pattern we are going to access the elements. So we create a function which generates this kind of values on the fly. Okay, that is the idea. So when we are using the for loop for ranging between 0 to 10, I used to do this way. So instead, I'm going to do, I will skip this logic. Okay, I'm just going to write a for loop now for I. Okay, for val in range of 10. Okay, if I print val, okay, sorry. syntax issue. Sorry. Yeah. So it is able to access these values. But if I print the range of 10, right, what is the value it has? It doesn't have any values within. Okay. It just says range of 0 to 10. So this particular object type is, it says range, but still it what it returns is it returns a generator. So generator is a place where we don't need to allocate a memory, but we know what is the order we are going to access, and in each sequence what is the value you are going to get it. I mean, it's like we have a standard pattern. So in that case, we can go with the generator approach, wherein we don't need to allocate a memory. That's it. Simple thing. Okay. So how we can implement this logic, we'll see that. For example, I'm writing a function. Okay. Yesterday I showed you a function. For example, I'm just having the same list of range of 10. So what is this doing? It is going to create 0 to 9. Okay, this is the list. I'm just going to create another list, a square. Okay, which is nothing but what we'll do using lambda function, which we learned yesterday. I'm just going to give a logic, or else we can use instead of lambda function, we can use list comprehension. Sorry, using list comprehension, what we do for val in a, for every value we are going to square this. So what you do, square uh, val squared. Okay, val to the power 2. Okay, so now if you print a square, you'll be getting all the values of a squared. Okay, 0, 1, 4, 9, all these values are squared now. Okay, so in place of 0 to 9, it's squared now. So but these values I'm not going to use it often. So for example, if suppose I'm accessing these values in a loop, okay, what I will do for val in a square, I'm just going to access these values in a sequential fashion. Okay, this way we can still access, we can do, but there is a problem here because we are trying to access these values after defining the list, and we are trying to access the values by iterating over each of the element, every element. So we are sure these are going to be the values. Instead of this, what we can do, we can define a function. Okay, for example, I'm just going to define a function which returns the same. Okay, for example, okay, I'm just giving this same thing. Define, okay, square. Okay, square is the function name I'm just giving. So whatever value you are passing as an argument. Okay, just giving a val here. Any name is fine. What I'm going to do, uh, just give me a minute. I made something mistake. Okay, okay. I guess this may not be the exact case. Anyways, you're going to this values and getting it. Okay. So this way also there is another way, but it will make you confused. I'm just trying to think of a simple approach where you can make use of it. Okay. So we know this value is getting squared and we are getting this. Okay. For example, we just comment all these things. Okay. What we're going to do? We are going to call a function. For example, we are going to call the function a square. Square. Okay. So function name is square. Square of, and we're going to pass a range of values. Or else I don't need to pass range also. I just wanted to check. Okay. Okay. Similar to this range, right? I'm just going to have this square term. Okay. Square range. I'll just give this name. That's what I was. This will not give confusion. So now what this square range function, I'm going to define a function now. So this square range is what is going to do. So whatever value I'm passing, suppose I'm passing 10. So till 10 squared. So 100, right? So before that 100, we are going to whatever, I mean, for example, 0 to 9, we'll going to return all the square terms. Okay. square values of that. This is the idea behind. Okay. So I'm just going to define a function called square range, and I'm taking a value. What is the range of value which has to go through? So now what I need to do, in general, what we do when you're creating all these values at one shot, we are going to return as a list. Okay. In that case, what you do, we need a for loop. Okay. We need a for loop val in a range of, let's see that this is something like n condition,
Use
right?
range value, range
Okay,
value better.
say something, yeah, that will be better. Yeah. Again, range wellness. Okay, I'm just giving a len or something. Okay, I'm just better. I'm just giving the range length or something. Okay, range length. Hmm? Okay, range len. Okay, now what we do, we can create a list. Okay, I mean, instead of creating a single list, what I'm going to do, whenever the square range is called, I wanted to return a value from uh, 0 to 10. That's what. 0 to 9, I will need to square it, right? Okay, in this case, there is a keyword. So to generate this, I mean, to write a generator, there is a keyword called yield. This is what we are going to use it. I will explain why it is needed and how it is used. Okay. So now this is the syntax of writing a generator. Okay. This function now acts as a generator. What we internally this range function does, I just created a custom function to create a square range. Okay. Now I remove all these things to avoid the confusion. So what I'm going to do, I'm just going to use this square range of 10. Okay. So the syntax is, let me repeat the syntax again. So what I did is I created a function called square range, and which is accepting the square, the end value as the length of this range as an input. And for every value, whatever with before that range length, we are going to square that term and giving it. Okay, it's not the square term. Okay, square is here. Sorry. So we are going to square that and return it. Okay. So instead of returning that final range of values as a list, I'm just using yield, not returning. That is the main difference here. Okay. So now if you see this code, so if I execute this, okay, you can see the values. I gave 10, 0 to 9. It got squared and we are getting the squared return values, right? Yeah. So this is the custom square function. I mean, custom square range function we have defined using the concept called generator. So what happens here is whenever you called for the first time the square range is called, if you call that value, now what it will do is we are taking the range length as 10, right? So when it goes inside this for loop, so what is this range value? The very first time, so let me break it down. So range of 10 for loop it will come. First time it enters. So range of 10, the first value what it will return is 0. Okay. First value will comes as 0. Okay. This 0 will be assigned to val and val 0 squared. 0 squared is 0. It will return. Okay. This value it will come back. But the control, right? When you come out of this function, the, the cursor will be still waiting in the, I mean, cursor in the sense, the control of this particular program is still moving back to the for loop because it didn't complete the for loop. As per this for loop logic, right? Only after this 10 elements, 0 to 9 elements, after consumption only, it will exit. But since we are using yield, so it will wait for each iteration. Okay. So now the idea you might have got. So it will not consume the complete list and return. It will wait for each iteration because of the use of yield. Okay. So now for the first time it returns 0 and then we are going to print that value. So it returned 0 now. Okay. Now second time we are going for this. Okay. But here when you're going for this call, so which is already waiting in the loop. So what it will do, it is going to call this particular range again, it will increment to the next value. For example, here it is 1. So the second value, the second element it will access and that element it will get squared and it will yield that value here again. So 1 you will get. So likewise, whatever values you give, it is not going to allocate any space for this. Okay, that is the main advantage of this. So we wanted to see how much memory it allocates when you are using a list and against this. Okay, that also we can see. Okay, so now you understood the concept of generator where it is helpful. Whenever the memory is a constraint and we don't want it to waste the memory space, and we know the sequence of data what it is going to be used, those cases we can use generator as a replacement. It is memory efficient as well as well optimized code you will get. Okay, so I guess I cleared. I mean, I explained it clearly. If you have any doubts, I will reiterate once again if there is any confusion. Okay, let's do one thing. Okay, so when I was talking about range, the space consumption, right, which is better than list. So how I can validate that point? Let me explain you. Okay, so there is a module called sys. So I think we never introduced the concept of module throughout this course. So module is nothing but someone has written. This is a standard library. They have written some set of functions. So here, as you used this range function, we used multiple other built-in conditions, right? Functions and all. If suppose you are using sorted, you are using length of, type of, all these functions are already defined. We don't need to import anything. Few functions will not get imported. Means it is not available until you import. So we need to explicitly import that particular library and make use of it. Okay. There is a library called getSysInfo, and sorry, sys is the library name. To know the size of any element which is allocated in the memory, there is a function called getSizeOf. For example, I'm just defining number one. Okay. Yes, let me check whether this. Yeah. So this returns in bytes. Okay, number of bytes. It allocated 28 bytes. So for example, here, if you see gets eyes of a string in place of one, if I'm giving string, what happens here? Let's see. We'll use a print statement. I will explain you why I'm trying to give this, trying to explain this is get in size, because we wanted to compare the size of list as well as the generators. Okay, list is nothing but iterators, right? So here they have allocated the size of 50 bytes. Here it is 28. So the size is different based on the type of data what we are using. So it is going to allocate a different size. So here in case of list, how much it allocates? In case of, so list is nothing but yesterday we as we discussed, list is nothing but an iterables, right? List can be considered as iterables. Okay, which is like an we'll access via iterators, right? And range is something it doesn't use iterator, instead it uses generator concept. Okay, so now if suppose I'm defining a list, what is the size it takes? Personally, I never tried. I'm just first time I'm trying to execute. Let's see what is the behavior of this. Okay, and now one, two, close, close, close. Okay. See, for the range of 10 elements, how much memory it is allocated when we are using iterator? When we are using generator, how much memory it allocated? Okay, we clearly see there is a huge difference. So here you can see 136 minus 48. So we have saved a space of 88 bytes. So as the size grows, suppose it's going 10,000, so the amount of memory, whatever we saved is huge. Okay. It is not going to change for the generator. Why? Because it is not going to allocate any memory. Whenever you call it, it gets generated. That's why we call it as generators. Okay. So now come back to the definition of generator. So generator is something like it will be useful for when you are knowing the sequence of values in which we are going to access, or in which we are going to use the values in a sequence fashion, it's always best to go with the generator. So it can be a square term, it can be like a multiplication. Suppose you are wanted to multiply each and every value by two times. So that also we can do. So all these things we can do with the help of generator, whatever you do with the list. List will be useful whenever you wanted to have a random access. For example, you have a list and you wanted to access the values in between. Using generator, we cannot do that because we have to. I mean, suppose if defining a list of 1 to 1000, I wanted to directly jump to the 500 value. I can just give a of 500, you will get the 500 element. But here in generator, we cannot do that. So it will follow the sequence. Okay. So that random access is not a solution. I mean, if you're going for a random access, generator is not a proper way. Whenever you don't need any random access, you are going to access it sequentially. Always prefer generator. Okay. Range is one such implementation given by Python itself, which is implemented internally using the generator concept. Whenever you wanted to customize this, whenever you wanted to use your custom generator function, as I showed you, this we have made a square range. It is actually not existing in the Python. We made up this. Okay. So we find this is useful, and the memory is also very effectively used. I hope it is clear. And we are mainly using the keyword called yield. As I explained, again I am explaining. Please try to understand. This is very important concept and little confusing also. I just wanted to be clear on this. Okay. So whenever you call this function, any function if you call, it will complete this function. It will come out. Okay. So it will not like it will stuck in that. So even if you call list of some whatever we did, so what it will do, it will complete that. It will consume all the elements whatever we gave the range, and it will give the end result. But here it is like unfinished business is there. It's still left. So we have used yield, which means it is going to be called again. So it doesn't matter how many times you call, it will get. I mean, until this for loop condition breaks, right? This condition is met, it will be waiting there. So it's like a program. It loads this value, it returns, and again it is waiting in the for loop. The next time this call it says, right, it is not going to call this function freshly. It is going to execute from the for, right? That is what the idea is. Okay, is it clear now? Can you guys confirm? If it is not clear, please let me know. I will just try to explain it again. Any confusion here, please let me know. I will explain. Mahesh, Inbag, Karthi, Edwin, everyone is clear with this concept? If you are clear, just say yes. If you're not clear, just ping me no. You want to explain again, I will explain. Okay.
Edison, what you can do is you can use the same thing using return and show him what is the difference.
Yes, yes. That's
Create a
a
list.
mm,
It will create a list, and the same thing can be achieved using this also, right? Generator. That is the normal way, and using generator.
yeah,
That way,
yeah,
they
yeah,
might be more.
yeah. That makes sense. Yeah. So what I can do, I can give you another one, which is using an not without using generator. So what I'm going to do, I'm just going to return a list. Okay. In that case, I'm just square list. Okay. I'm just given a function like this. I'm just going to give this list length. Okay. The same logic I'm going to use for val in. This I'm just taking the liberty of using the same range. Okay. Sorry. And instead, what I'm going to do here, I'm not going to return at every moment. I'm just going to construct a new list. Okay. This is how we initialize an empty list, and we are going to append these values in this list. Whatever values we are going to have. Okay. Okay. So I will add a print statement. Better. I'll just give the value. Okay. Okay. I'll not confuse that. Okay. I'm going to use the same here. What I'm doing here is I'm just going to capture inside square list function. Okay. Inside square list function, what are the values we are generating? And this particular value, I can give this as a square term. Okay. Instead of giving what is the value you're expecting. So I can print. Okay. That's fine. So now let me show you one simple, instead of using this for loop, if I'm calling this square list of 10 and square range of 10, let me use a separate cells for this, okay? So that will understand what's happening. I'll use one more cell for this, okay? For range. Okay. So now I will execute this particular, I'm defining two functions, square range and square list. So square list, what it does is it takes the length of the list and we are creating an empty list, and then whatever values we are getting for each, whatever length we give, for each value we are squaring and then we are appending to the list and the end list is returned. Okay. This is what we are doing here. But here we are not returning, we are using yield function. Okay. Yield keyword. Okay. So let's see the difference. So first I execute this. These two functions are defined. And whenever this function is called, for every for loop entering, we are just printing this inside square list. For every entering, for every iteration over the for loop, we are printing inside square range. Okay. So now if I will execute this. Okay. So as you see, the square list function complete for loop is executed and the list is created and returned. Okay. This is what happens. When you use this one, it is not returning any element. Okay. It just uses this generated object. Okay. That is the difference. So it is not going to execute until unless you are going to use it. So whenever you are using this for loop, right? Okay. I don't know whether I can stop in between or not. Let me check. Okay. We'll see the results. Okay. First I will use the square list. How the results are. Then you can identify the difference. So whenever the square list is called, the moment it is called, before going through the loop, we are getting all the values inside that and we are returning the print statement. As you see, the statement starts after that. Okay. First it created the list and we are traversing through the list. Okay. This is the difference. If suppose I replace this particular function, this particular loop where the list function is replaced with the range function. So you can clearly see for every call, this particular for loop is executed for every call. Okay. Whenever I wanted the values for a second element, so this went inside this particular for loop and it executed this statement and it waits for the next condition. Okay. That is why we are getting this way. So you can clearly see that there is a difference. Whenever using square list, the the complete list is generated and then we are just traversing the values. This is where we are allocating the memory for this complete list and we are accessing the values one by one. But here what I am doing whenever using range, I'm not allocating memory for each and every value. Instead, it will generate dynamically. Got it, right? I think this explains better than the last, right? Yeah. Thanks, Lucky, for this input. Yeah. Now it is clear, guys. Mahesh, Inba, and all. Kati. Is it clear now? Please confirm or else. Yeah. Thank you. So this is one of the main concept which is used in Python. I guess this is also one of the unique concept of Python. So whenever you work in Python, I always insist to go with Pythonic thinking. So when you work in other languages, we do differently. But when it comes to Python, there is a way of do program in Python. So this is one of the Python thinking concept. Okay. So instead of going for a random list, I mean generating a memory for a complete list, you can leverage this generator. Okay. That's the idea behind. So I guess this concept is clear now. Based on that, I will just move to the next topic. Okay. Do you guys have any questions? Please let me know, or else I will move to the next. Okay. And this is one new thing which I introduced now. So to check the size of any data type, we have a module called the sys. We have to import that module first before accessing it. Then you can use get size of, and using this any particular type, it can be a primitive type, it can be a collection type, whatever it is, you can pass it here and check the amount of memory it is using. So to know what is the memory it is used under the hood, so on the actual machine, so we will able to see using this function. Okay, that is the purpose of this. So by analyzing this, by monitoring this, we can optimize the code. So that is what I just showed you, how much memory is used by this list and then range. Okay, that's the thing. So most of the people, I've seen some content on range, people explained this range is as an iterator. Okay, so range is actually not an iterator based, it is actually generator. Okay, so wherein it will not allocate memory at one shot. Hmm? Okay, that's the thing. So let's move on to the next topic with this. What is the next topic? I wanted to explain you the concept of map. Okay, map is something like, let me explain the syntax of map. So what is the syntax of map? So we are going to have declare have this is a keyword actually. Map is a function. Okay, what we are going to do, we are going to call a function. Okay, that function, what it does is, we are going to give one more iterables. Okay, these are the two arguments. Iterables are nothing but, say for example, our list 0 to 10. Okay, for each element of this list, this function will manipulate something and it will update the value. Okay, that is what it does. Okay, this function can be a regular function, or else we can use a lambda function as well. Okay, lambda function is mostly they prefer using lambda function as well. So in our case, we might have seen how to create a list comprehension. So even we wanted to create element wise, we wanted to do some updates. We might have already done. Okay. For example, what I do is, at the same example I'm taking, list a range of 10, which is 0 to 9. I wanted square of a square. What I will do with the list comprehension, I will explain. Okay. So what you do, sorry, better have this habit. I don't want to. Val in A, for each val in A, what we are going to do, for every element, we are going to square the term. Okay. Now, if we print A square, you will be getting the squared terms, right? This is how we do. So this is called as list comprehension. The same list comprehension function approach can be done. The same thing can be done using a map function as well. Okay. So list comprehension is one way. Using map also the other way. What it does is, it takes this element. Okay. Here in list comprehension, we are taking each and every value of this iterable. We are running an expression. Okay. So what we are doing, each val we are squaring that term, and then we are I mean appending for each and every value. So that's why we are getting a new list which is like all the square terms. Instead of doing this, we can use the map as well. Okay. Let me comment this. We'll create a map. Okay. A square term. I'm just going to use the map function. Since I used lambda function in the last class, I explained lambda function. I'm just going to leverage the same here. Okay, lambda. Okay, I'll write the logic later. So let's see the E. Okay, this is the iterable A. So how you define lambda? So better we'll put it inside this bracket. Okay. Lambda. what is the parameter? What are the parameters we are going to have? Only one element at a time we are going to take. So we can use that val only as the term as we used above. And what is the operation we are going to do? Val square, right? Okay, just give me a minute. I don't think we need this particular bracket.
Colon, the val colon.
Oh, exactly. Something is missing. Yeah, yeah. So let me give some space so that you can get an understanding what I'm doing. Okay. So I created a function. This function is nothing but is going to map. Map is nothing but what is that? So if suppose you have some value of each for each element, we are going to do some calculation mapping to that function. Okay. Here we are defining a function for each element. We are going to map to this function and we are going to manipulate and return it. Okay. That's what it is going to do. So now the expectation is we need the same a square term. Okay. Let's see if it is working. Maybe I can have one more print a square using list comprehension. Okay. LC and using map. Okay. Let me print using list comprehension using map. Okay. What happened? Okay. So is it map is also kind of generator? I
I think
guess
in Python 3, everything is generator
generator.
only.
Yeah, 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 yeah. The latest version of Python has all these repetition of. I mean, we know what is the value it is going to generate. They have used as a generator concept. As you see, the first one it returns the complete list, but here it is not returned. So what we can do is we can enclose this inside a list casting. Then we'll get the list. Okay. Yeah. Now, if you see the same list comprehension, whatever we have done, so we have used the map to generate this. Okay. So here, if suppose we don't need to generate the list at one shot, we wanted only on demand we wanted to generate, we can still go ahead with the map alone. Okay. I guess that also will work. Let's check that because I have used a very old version, I guess, but still we can do that. Okay. So what we do instead of converting this into a list, let's confirm that whether it is accessible by each element. Okay. Like a generator. Okay. What I'm going to do for loop val in a square map. Okay. So this is a generator object which is going to be accessed every time. Okay. Yeah. As you can see, the map values are accessible every time the loop is executed. But this uses a generator concept. Again, it is more memory saving than this. Okay. So this is one of the other way to generate the, I mean, create a generator as well. Okay. As I showed you using yield, even map also internally does the same. Okay. Like range function. Yeah. So let me repeat the same thing, whatever we are trying to do here, in case if I confused you. What we are trying to do here, I will replace the values with same list. Okay. So whenever you wanted at each element wise in an iterable, you wanted to do some operations, we will either go with list comprehension or map. So these are the two options we have. So we know how to use the list comprehension. This now we are going to see how to use map function. Map syntax is actually map uses function and iterables. This function is the one which is going to operate on the each element, and we are going to yeah, we are going to access these values. The mapped values will be going to get it out of this. Okay, that's the idea. Yeah. So now whatever we have done is we use the lambda function in place of that function, and we use the a that list which is created above. We use that, and using that we created a list. That's it. So map is an alternative mechanism to create this. Uh, what to say? Element wise operations. Okay, similar to list comprehension, but it has its own advantage because of using this generator. But one more thing I just wanted to tell about generator, instead of doing all these things, okay, for creating a generator, we are struggling all this way, right? We can use the generator in a different way using the list comprehension also. We should be able to generate a, we can create a generator. The syntax is same, but it is little different, okay? Almost same. Suppose I wanted to create a generator for a square. We use the same syntax, okay? Just replace that with a bracket, this. Okay. So here what it returns is it returns the list immediately. Here it is going to return a generator. So how we can ensure that? We can check the size. Okay. Let me add this import sys and check the size. Okay. Get size of a square LC and generator. Okay. Something missing. Right. Okay. As you can see, this is 10 values. That's why you're not able to see much difference, but still it is there. The list comprehension is giving a 184 and the square gen is giving 104. Okay. If you go for bigger value, you'll get to know. Suppose I'm declaring 100, you will just see. You can see the difference. Right? Let me use 10 only because we will need to use the for loop to access this. And I'm just going to use a for loop here. To prove this is a generator, I just wanted to do this. Okay. What I'm going to do for val in a square gen and I'm just going to print val. Okay. 0, 1, 2, 3. So the generator can be created using the same list comprehension syntax. Only thing the square bracket will be replaced with a rounded bracket. Okay. So this way also we can create. And we are here to explain the map, but I thought of explaining since I already explained generator. So using the same method also we can create generator. I thought I will explain that. Okay. So these are the kinds of provisions Python provides and various alternate solutions are given. So based on your need, based on which is performant, we can pick your choice. Okay. That's it about map function. Let me move on to this one. Is that filter? Okay. So till now it is clear. Guys, please answer. Just I'm expecting an answer yes or no. That's it. No need to tell anything in the chat. If you are clear, you just tell me yes. If it is not clear, just tell me frankly it is not clear. So whatever we have seen is two concepts. One is like generator using the yield and map we saw. These are the two concepts we saw. So generator and map is clear, right? Please confirm if it is clear. I just want to know you guys are able to follow this or not. Yeah, thanks, Edwin. Uh, Others, Mahesh and one more vote I need. I'm just looking for. You guys are clear. I will just move to the next. Okay, let me move on to the next topic. Assumed it is clear. If it is not clear, please stop me now. Okay, I hope it is clear. Okay, let me move to the next topic. Okay, so the thing here is what we found is okay map. So now we'll move on to the topic called filter. Okay, filter is something the name itself suggests. What we are trying to do, we are going to add a conditional conditions to that so that we'll filter only whatever values meet that condition. So this also we covered with a list as well, but list comprehension as well. But still we can do this operation with filter. The syntax of filter is we use the filter function. We use the same function argument and one more this one iterables. But here the catch is the function has to return true always, true or false. It has to be return a boolean value because it's a kind of condition. Okay. So I'm not going to define a function here for a simplicity, I'm just going to use the lambda function. So you will get familiar with lambda function as well. So mostly places like map, filter, people will not go for a separate definition of function. People will use a lambda in the reality, in the production environment, wherever they develop. So I'm just going to follow the same syntax here. We'll work on that. Okay. Thanks, Mahesh, for confirming. So how do we use filter? I'm just going to define, first of all, how we use a list comprehension. I'm going to take again the same example, range of 10. I'm going to have 10 elements. Okay. Okay. For example, I'm just going to take 20, 0 to 18 actually. So sorry, 0 to 19. I needed only odd number, even numbers. Okay. In that case, what we do for a underscore even numbers only I wanted. Okay. What I will do for using list comprehension method. Okay. For val in a, what we do, we are going to have a condition. If condition a modulus of 2. If a modulus of 2 is nothing but a remainder after dividing by 2, what is the remainder? If the remainder is equal to 0, which is which says the number is even number. Okay. Only for then we are going to have a list. Okay. Now if I print a, now if I print a underscore even, my expected value is wrong. What is it?
No, val.
Sorry, supposed to be 1. And okay, yes. Wait, something wrong here. Here also you have to use val. Okay. So the condition has to be based on this element. It's not the list. I used the value a here. A is nothing but the list name. So I wanted the value to be used. Okay. That's the wrong. Thanks, man. Thanks for pointing out. So now as you see, the original list is from 0 to 19. But whatever elements we wanted to pick, selective filters. So this condition ensures that we are filtering only the value, whatever it is, divisible by 2, which is nothing but the even numbers. So we used this list comprehension method to achieve this. The same thing can be achieved using filter. Okay. So now I will introduce the filter function, how we use a underscore even filter. I guess this also returns what is that? Generator. Let's see that. Okay. Lambda. So here, what is the argument we are going for each element we are going to operate? Okay. I'm just giving the same example, lambda val. And what is that value? We are going to check the condition. We are going to return the condition val, right? Val mul val modulus of 2. The same condition, whatever you are doing here, 0. Okay. And here, what I'm going to do, I'm going to pass the list. If for time being, I'll just convert this into list type so that I'll not run a for loop again. Okay. Anything is missed here, I'll correct it. Like, hope this works. So here, I'm just forgot about this list conversion. Here, I'm going to, this is the function part. Okay. And this is the iterable part. Okay. And this is just casting in case it returns a generator. Yeah. So as you see, the list comprehension with condition is equivalent to this filter expression, right? Filter. So the same function which I'm doing, but only thing is I wanted always a value to return of true or false. In case of filter, what is the expectation is if the value is true, then only it will consider that element. If the value is false, it will ignore that element. If suppose you are doing instead of placing this something, you are doing some other operation. Suppose you are using only val, so which means the condition is always true. Okay, so it will not. I think it will give all the values. Okay, so why it is not returning 0? That's a unexpected result, but I can answer you. So in general, in evaluating a conditional expression, whenever it sees a zero, it is considered as a false. In case of a string, whenever there is an empty string, it is considered as a null. Okay. So similar to that, that's why only for zero it filtered, but other values it came. Okay. That's the reason for this behavior. I guess it is clear. And always you should have a conditional check. You should not have any expression apart from conditions. So that's why I'm just saying if the value is divisible by 2, that is what we are checking here. Then we execute this filter condition, you'll get this. If we do without this list conversion, it will return generator. Okay. The same logic, whatever said, in place of square bracket, if you use a rounded bracket, this list comprehension become a generator expression. You will get generator. Right? Okay. That's it. So now the filter logic is clear. I hope it is clear. Nothing changed much. Only the thing is the result, end result is uh okay. The end result is just we are getting true or false. Okay. We are having a conditional check. So in map we don't have conditions. In filter we have conditions. Similarly, there is one more operation called reduce. Reduce is something. Let me show you what is reduce. So earlier reduce was an implicit standard library function. We don't need to import any library for that. But now they have made it like a separate module. Okay. So it is part of this func tools. Okay. So when you wanted to import only reduce, what we can do from that module name, import reduce. Reduce is the function name which you're going to use. Okay. The syntax of reduce is same way whatever we do the same thing. What it does is, okay, just give me a minute. Syntax. Okay. Reduce. We take a function, iterables. Okay. There is one more optional parameter called as initialization. Okay. We can give some initial value what is required. Okay. So reduce what is this does. Okay. For example, if I'm having a list, same example I'll take. Okay. A range of 10. Reduce is something on each element of this value, we are going to do some kind of operation. Okay. So for example, I'm just going to sum of all these values. I'm going to sum of all these values. I'm going to use this reduce function. So reduce is something like we are going to get the summary of this. Okay. So it's like not on the, it will operate at the element level, but it will be summarized. So we might have seen a for loop like this. For example, val in A, okay, and just put it in range of 10. I'm going to have one sum of value from 0 to 9. Okay. Or else, for example, sum of value from 0 to, yeah, 9. Well, let me explain this part later. Okay. I'll explain this function how it does. So for every value, what we are going to do, we are going to add to the sum. Okay. Sum is equal to sum plus val. Okay. So at the end, we are going to print the sum. Okay. What it is doing is it is trying to add all the values from 0 to 9. 0 plus 1 plus 2 plus all these values get added and it got the final result. This particular expression is going to get replaced with this function. For each element, it is going to do this kind of operation. And this particular this thing, right? Sum is equal to 0, whatever we keep. This is nothing but the initial part. And this particular place, what we are doing is actually the function logic will goes here. Okay. So let me explain. If I use 10 here, the overall result should add with 10 more. Okay. So in place of 45, it should become 55. Okay. I observe this value. The same result we should be able to obtain using the reduce. Okay, that is what we are going to look into. Just using I'll create one more thing using reduce function. Okay, what I'm going to do, I'm using reduce. Let me introduce this. Okay, introduce reduce, and we'll go with lambda only again. Lambda function. How many values we are going to take? Here we are going to take two values. Okay, A and B, and I'm going to return A plus B. This will confuse you. Let me tell you. Okay, let's return A. Okay, I'll just make it as X and Y so that avoid confusion. That list name is A. I'm going to return X plus Y. Okay, and iterables are nothing but A, and initial value of this one I'm just going to give value called 10. Okay, I'll just assume 0. Okay, so this X is nothing but the initial sum which is going to take. Yeah, let's see. It's been a long time when I haven't used. Is there a syntax error? Reduce is not defined. Oh, okay. I have to import. To use the reduce function, it is not a built-in now. We have to use an import. Okay. Now it is done. Let's print the sum reduce. Okay. So now I'm expecting a proper result here. And okay. So now what it happens is I initialize the value 0 here. Suppose I'm not initializing this value, what will happen? Yeah. The default value for x it is taken as this one. So here I wanted to give you a better picture. Here x is nothing but the sum. Okay. What I did here on the above. And y is nothing but the value from the element. Okay. So now what I'm going to do, sum plus y is nothing but sum plus val. The same expression. Here what how it will do is in case of reduce, sum is equal to sum plus val. This particular expression is internally evaluated. Okay. And in case the initial value is not supplied, it will consider 0. If suppose we are supplying the initial value as 10, then we'll be getting the same result as this. Okay. So this is the concept of reduce. So what happens is whenever you want to reduce is something like you are reducing complete list elements. We are not going to access it. We are reducing to some meaningful value. Here, what I wanted is I wanted to sum of all these values. I wanted to calculate. That's why I use this. There may be some other requirement you may need. So I wanted square of each term and then I wanted to add the value. That way also we can do. Okay. Instead of that, what you do that in that case, I'm just going to use this value squared, or else I just make it 2. It will be easy to see the results. Okay. In that case, what happens? Let's see. So now what is the problem here? Why it returns 100, but I think the value will be 100 only. Yep. You can see, yeah, sorry, add some extra characters. It's better to use bracket. There are some operator precedents which I didn't cover in this session, but you can always go through. There are plenty of documents available on that. But always, if you enclose in the bracket, always the bracket will get the preference. Okay. Value multiplied by 2. Okay. So here the end result is 100. Here also the same value you got. So now you understood how we can use the reduce. I think this will unnecessarily confuse you. I just don't want to get into this. To give an understanding what happens in between internally, I just added this example. So let's avoid this complexity. Okay. Now the end result should be both 55. Got it right? So I guess now the concept for this reduce is also clear. Yeah. With this, we covered these three main functions. The same thing also can be done using this particular logic. I don't know whether we can use list comprehension for here. I don't think we cannot use list comprehension because we are having an end scalar value, not actually a iterable here. It's a kind of a single value. Okay. So in that case, so for example, whenever you wanted, there are some built-in functions also available in Python for list, right? So I can have what are the for adding of all the values inside. What I can do sum of a if I give, I guess something wrong. Int object is not columnar. Oh, I might have used a different value. This is one of the reserved keyword I used. I guess I made mistake. Yeah. Mm, there it is called again. Some. Where is it? Sum of a. Oh, it's giving error at this location only. Int object is not columnar. Where I define int, I removed it, right? Okay. I guess something went wrong. I'll check that. We need to restart the kernel. The sum is already defined. I need to restart this. Same function should be executable. Loki, sum is the right function name, right? I'm just confused here.
I think that may not be available for a list. Directory of list you check. AIR of A.
Ah, okay. I think it is there, I guess. Let me check. Oh, it is not. 1, 2, 4. Oh, again, it is giving, it's not coming out of that, right? Let me do this in
You
the
check.
Python.
DIR of list you check.
Yeah. Yeah, before that, I just wanted to confirm. I believe this is there. Yeah. The problem here is whenever you use the keyword, right? The keyword function, whatever built-in keywords, if you try to override this kind of side effects, you'll get. Because sum is defined as an integer type. Actually, it is a function. You see here, it works, right? Sum of 1, 2, 4, which is the sum of all the values. This is similar to the reduce function. They have a built-in reduce functions where you can make use of this. Whenever you wanted something peculiar or something unique you wanted to handle, you can write your own reduce logic. Okay, that's the idea behind. If I restart the kernel, it will work. So I don't want to do that. Let's fine. Okay, I'm slightly confused. Okay, so that's the main concepts today I wanted to discuss. I guess we have done with that. What else there? Let me go through the list. Okay, map filter reduce. Okay, try exit finally and file IO. Okay. Oh, you guys are ready to continue, or else you want a break? We'll just take a 10 minutes break and come back. But please do join. Don't need to leave the session. Please keep it open, and you can take a break and come back. Okay. I think you can stay connected. I will stop sharing so that your data also will not be consumed. We'll take a 10 to 15 minutes break. We'll come back by 10:30 and we'll discuss on try catch. Okay, try catch. I mean, try accept and file IO. These are error handlings, and one is that file access. Okay, let me stop the recording for this session.